So here's our video summary of the paper by Blake Austin on the Beijing National Stadium. I'm Darren Peets.
I'm Dan Minarsik.
I'm James Otto. The Beijing National Stadium was built for the 2008 Summer Olympics and was meant to be a status symbol for China. They broke ground on December 2003. Out of the $500 million budget, the Chinese government contributed less than half to the building. An investment group picked up the rest of the budget. The stadium is able to hold 80,000 seated fans, but is able to be expanded to 91,000, which they did in 2008 for the Olympics. Because of the look of the building, it has become known as the Bird's Nest. Looking at design for the stadium, out of 13 competing designs, the final design that was constructed was the winner. Two components make up the stadium: a steel exterior and the interior seating bowl. A simple geometric underlay was overlaid with a chaotic structure. The chaotic structure is intended to be non-load bearing. These three pictures display the simple geometric and chaotic structure mentioned in the previous slide. The top picture shows the primary structure, the middle shows the combination of the primary and secondary, and the bottom is the picture of the completed structure.
Due to the general design of the structure, a new steel grade had to be developed to handle the forces that occur. Q35 and Q460 steel were the types developed to ensure the structure had enough durability to withstand the different forces from the double curved roof shape. Tube-shaped members were used to accommodate for the shifting forces. The workers for the project had to be specially trained to make the specific welds for the unique members. Approximately 42 tons of steel was used in creating the structure. The entire structure, with the concrete included, weighs about 45,000 tons. The primary structure consists of 24 V-shaped truss columns, and the structure has a total vertical live load of 11,500 tons and about 3,090 tons lateral load.
Alright, so these two pictures show a little bit about the load paths. It should also be noted that to help reduce some of the wind loading, the structure is left pretty open. As you could see in the earlier pictures, a lot of the structure just has gaps in it to allow the wind to pass through, reducing the wind load. So the seismic load was probably more of a consideration when they had to design for lateral loads. But as you can see in the top picture here, all the red points represent columns where the load would have been transferred down to the foundation, and the green arrows show a little bit about how the load moves from the center of the structure out away towards the outer columns. On the bottom there you can see each of those four arrows on either side represents one of the red dots from the above picture. Those would be the columns where the load is transferred to the foundation, and then those two purple arrows are representing the foundation, transferring the load from the building into the ground itself. As far as seismic loads, it was built to withstand roughly an 8.0 magnitude earthquake, and the steel was developed primarily for this purpose because it had to have the right strength, weight, and flexibility to handle just the seismic design, the variability of forces, and the extreme conditions it would be in. Also, the concrete bowl was built separately from the steel structure, which allows the two parts to respond independently and gives the building a slight advantage when being designed for seismic loads. Just some final thoughts. The secondary tubes on that chaotic outer overlay were made of the same material as the primary structure, so that anyone walking through the building wouldn't be able to tell, and it just looks like a bird's nest, as we kind of mentioned before with the nickname. Just very chaotic, and it's hard to actually pick up the load bearing or anything. You just see this mess of steel. And actually there was over 22 miles of steel used to make the structure, so obviously there's a lot of steel in there. Another interesting fact, there are no obstructions of the field from any point in the stands. There's no columns or anything to support the roof that would interfere with seeing anything on the field, which was obviously huge. Plus, you don't want to have people sitting in the stands not able to see anything. And another note, they actually originally designed it with a retractable roof over that central span, but due to budget concerns, they had to cut that out, and that actually reduced that original $500 million budget down to $290 million.